Exercise 5b, question 7. I've done the first part of the working and I've simply separated the variables and we now have to integrate these two functions. They're standard integrals. I can either use arcsine or arccos. I've chosen to use arcsine, so I end up with this line here. We're given some conditions that will allow us to find the value of c, so I've substituted those in, and that has given me the value of c as pi over 6. I can now write the solution down as shown. The next thing I'm going to do is take the sine of each side. So we'll have this line here. I'll now use the sine of a plus b formula, which will give me this. Now what you should notice is from the first part, the sine of arcsine x will simply be x. The cos of pi over 6 is root 3 over 2. The sine of pi over 6 is a half. The only thing we're going to have to think about is what is the cos of arcsine x. The easiest way to explain this, and in fact the easiest way to do this, is simply to sketch down a little triangle as shown, where I've got theta, and I've set it up so that the sine of theta, opposite over hypotenuse, will be x over 1, i.e. just x, and by Pythagoras I can find the missing length as the root of 1 minus x squared. So I can now claim that the sine of theta is equal to x, and that implies that theta, in fact, is the arcsine of x. Therefore, the cos of arcsine of x, in fact, is now just the cos of theta. And the cos of theta, adjacent over hypotenuse, will be given as shown, the root of 1 minus x squared over 1. I can now start to fill in the details in my working, and it comes out quite simply like this. X times root 3 over 2 plus a half times by 1 minus x squared. There's one job left, multiply throughout by 2, and we've got the solution in the desired form, and we can see that k in fact is equal to 3.